because we'll just look around us, no? And ayan, thank you for recording. I always forget, no? I always tend to forget to record, no? So thank you. And as I was saying, no, today we'll just look around us, no, and look for the mathematics around us. So saan nga ba natin makikita? Saan nga ba natin di pala naka-on yung cam ko. Ayan. Saan ba natin matatagpuan, no? Alin mga bagay sa paligid natin yung makikitaan natin ng math sa kanila. Okay? So with that, allow me to share my slides because this will be a relatively long discussion also, as this will be a two-part discussion. So for the first one, can you see the slides now? We'll be having mathematics in the arts. Kita na po ba ang slides natin?
Yes,
Yes,
sir.
sir.
Yes.
Opo.
Yeah. Ayan. Okay. So for here. And so we might be all familiar with what we call as the golden ratio. So as mathematically speaking, kapag sinabi natin golden ratio, it's denoted by phi, or sometimes they refer to it as the Greek letter phi. And it is an irrational number. So like the value of pi, no, is a non-terminating, non-repeating decimal. So para siyang yung Euler constant na diniscuss na rin natin dati. So the value of phi is 1.618033 and so on and so forth. So again, hindi yan matatapos. So is a non-repeating, non-terminating decimal. But most of the time, we use the value 1.618, no, as a good approximation. It's a four decimal place value approximation. And we say that shapes or figures proportioned according to the golden ratio. So ibig sabihin, when you get the ratio, kunyari, of the sides, or you get the ratio of in those shapes or in those figures, and you find the golden ratio almost close, no, not necessarily equal to the golden ratio, but if they are proportioned in such a way that they approximate the golden ratio, then we consider them as aesthetically pleasing or mathematically beautiful. Right? So sana all, no? Anyway, we'll have a discussion later on that. And many artists, no, like Leonardo da Vinci, sabi nga natin, when we talked about da Vinci before, Leonardo da Vinci was very much aware of his mathematics, and in fact, his applications of mathematics are in his artworks. So sabi nga natin nun, si Da Vinci ay isang illustrator, no, doon sa aklat ng kanyang guro, no? So he applied his mathematics in his works. Okay? And many other artists incorporated the golden ratio in particular in their artworks. And mamaya tingnan natin ano-ano yung mga yun. Now, how can we calculate, or how can we find the value of the golden ratio? So let's think of a line segment of measure 1 unit, or of length of 1 unit, and then we divide the segment into two parts, wherein one side will be of length x. Okay, so this will be let's think of it na yung x yung mas mahabang part. Okay, so let's consider this part here to be of length x, and then therefore, dahil 1 unit yung buong segment, this part here will be of measure 1 minus x, di ba? And now, to find the value of phi, we look for, or we get the ratio of the entire, again, we find the ratio of the entire segment with the longer leg, which is x. Okay, so that will give us the value of phi, and we want to proportion it with the value of the longer side, or the longer part, x, over the value of the shorter leg, which is 1 minus x. So it's always the longer part over the shorter part. Okay? So ganun siya. And then to solve for phi, sabi ko nga, we just find the value. And curiously, the value of the x, the value of the longer part, which we can find, is 0.6180. Okay? So, parang yung decimal numbers niya, almost the same, di ba? With the value of just the decimal numbers. Almost the same with the decimal numbers of the golden ratio, okay, which is 1.6180. Okay, so that's how we find the golden ratio in a line segment. Now, whenever we have triangles in which the ratio of the leg over the base, diba, this is the base, approximates the golden ratio, we call that as a golden triangle. Okay, so sabi nga natin, hindi naman necessarily equal. Okay, so maybe just an estimate or just an approximate, no, of the golden ratio. Kasi nga hindi naman talaga natatapos yung decimal numbers ng golden ratio. And most of the time, since we want symmetry, later we'll have a discussion also on symmetry. Most of the time, we consider isosceles triangles, no? Yung mga triangle na equal yung measure or equal yung length ng two legs, no? So that's an isosceles triangle. And again, kunyari in this specific triangle here, if we get the length of AB, of side AB, and the length of side BC, and then we divide them, no, the longer side over the base, and we get an approximation for the golden ratio, then we call this as the golden triangle. Okay? Then we also have what we call as the golden rectangle. So if we have a rectangle whose sides are in proportion of the golden ratio, we call that as the golden triangle. Golden rectangle. Yung ating mga papel, if you get the ratio of the length over the width, they are approximating the golden ratio. Yung mga index card, kasi nga gusto natin na aesthetically beautiful, no, yung mga bagay-bagay. So, mas magandang tingnan, so hindi makitid, hindi malapad, no, yung mga papel if they are approximating, or the ratio is if the ratio of the length and the width approximates the golden ratio. Kaya yung mga index card natin 3/5, 4/6. So again, hindi siya exactly the value of the golden ratio, but they are good approximations of the golden ratio. Okay? Questions? Questions so far? May tanong po ba? Questions? Thank you, Piolo, Eileen, and Adrian. And James. All right. So that's the golden rectangle. And if we construct golden rectangle side by side, and we connect the corners of this golden rectangle, we get what we call as the golden spiral. So for example, this is a golden rectangle, and then kung kunyari itong part na ito, itong golden rectangle na to, ay magiging part naman ng isang mas malaking golden rectangle. Tapos itong golden rectangle na to ay magiging part ulit ng isang mas malaking golden rectangle, and then so on and so forth. So itong part magiging golden rectangle ulit, tapos itong part na to magiging part naman ng mas malaking golden rectangle. And then if we do that, no, a number of times and connect the corners of these golden rectangles, we will actually be forming a golden spiral. Okay, so this part and then going outwards. Okay, so this is our golden spiral. So this corner here to this corner, to this corner, to this corner, to this corner, and so on and so forth. Okay, so that's the golden spiral. And in fact, in the arts, the golden ratio, the golden spiral, and even the golden triangles and rectangles are very much in use. Okay? So tingnan natin, saan ba may mga applications itong mga pinag-uusapan natin. So as we have discussed earlier, si Leonardo da Vinci ay ginagamit niya, no, yung kanyang mathematics sa kanyang mga likha. Okay? So in his artworks. So the Mona Lisa, of course, aside from being known na 'di ba wala daw siyang kilay si Mona Lisa. Aside from that, uh, aside from that known notion about Mona Lisa, we are considering Mona Lisa as aesthetically pleasing. Sabi ng ibang scholars, ibang artists, si Mona Lisa ay isang larawan ng isang empowered woman. But more than that, we consider Mona Lisa as beautiful. Bakit? Because in fact, you can encapsulate. I am not really familiar with the term, but mathematically we call it as inscribe. So pwede nating ipasok si Mona Lisa sa loob ng isang golden triangle. Okay, so if we create a triangle from the tip of the artwork, from this tip of the artwork going to the base, we are formulating or we are creating a golden triangle which will contain Mona Lisa in entirety. Right? And then if we can also create a golden, we can also create golden rectangles, a sequence of rectangles starting from the face of Mona Lisa. And if you will observe, if we will formulate or if we will form a golden spiral, the golden spiral will also contain the entire face of Mona Lisa. And that's how pleasing. That's how pleasing Mona Lisa was painted by Leonardo da Vinci. So sabi nga natin, Da Vinci was very much aware of these mathematical concepts, okay? And he applied it in this in his works, so particularly Mona Lisa. Okay, so that's Mona Lisa, and then we also have the Vitruvian Man. And if you have watched the Da Vinci Code, or if you have read the book of the Da Vinci of Dan Brown on Da Vinci Code, it started with the Vitruvian Man. So bakit ba pleasing din ang Vitruvian Man? Later we'll have a discussion on where can we find the golden ratio in our body parts. But ang kakatuwa lang is that the Vitruvian Man shows precise measurements following the golden ratio. Halimbawa, yung arms niya to his the measurement of or the height of the Vitruvian Man over the lower extremities. It gives us the golden ratio and so on and so forth. Okay, so isa yun sa mga kagandahan ng Vitruvian Man as created or as painted by Leonardo da Vinci. Okay? Okay po ba? Okay? Okay. Are we still good? Pa ba tayo? Yes, thank you, Zarina and Piolo. Okay, now, Adrian, thank you then. in construction, in architecture, in engineering, we also follow the golden ratio, not only for aesthetics, not only to be beautiful, but construction wise, it has something to do also with the strength of the materials and so on and so forth. Okay? So the pyramids of Giza, as we know it, follows the golden ratio. So if you get a triangle in it, and then syempre solid figure yan. So if you get a two-dimensional triangle contained in this pyramid, you will see that the hypotenuse or the ratio of the hypotenuse over the hypotenuse of this triangle over the base of that right triangle will give us an approximation of the golden ratio. Okay, so that will be 1.61950. Sabi natin, ang approximation natin ng golden ratio is 1.6180 and so on and so forth. So it's again a good approximation of the golden ratio. And to think of it, sabi natin yung mga Egyptians nung inaral natin, sila when we talk about numeration systems, diba? Inaral natin mga Egyptians. They are already aware of mathematics, and their applications are more on geometry. Although their mathematics was not really that formalized then. but they were aware. They already had notions. They already had concepts of. They already had mathematical concepts, and they applied it. For instance, in the pyramids of Giza. Okay? We also had the Parthenon. So, syempre, no, in Athens, in Greece. So, this is where we are more dito sa Greek civilization, dito na mas na-formalize, no, yung notion of mathematics. So, we can expect, no, that their structures, their architectures ba yung tawag to? But their structures, no, their buildings, no, follow mathematical concept. So in particular, we have this Parthenon, although hindi na siya buo, no, sira na siya. This actually follows the golden ratio, and in fact, you can create the golden the golden rectangles, no, starting from the roof of the Parthenon, consecutive rectangles, therefore forming also a golden spiral. Okay? So going back to the art, so we have this painting. Tapos kung mapapansin natin, even the dimensions of this painting or this artwork are also following the golden ratio. And kung titingnan natin, if we draw a triangle, no, an isosceles triangle from the tip of the painting passing through the nose of this subject, and then to this, no, to this part, to the chest of the subject, we are actually creating a golden triangle. Okay? And then, makikita natin, we can also form a golden spiral, which again encapsulates the entire subject. Okay? So, ganun siya na-create. This is how this painting was made, no, by the artist. Okay? And then in photography, pwede din, no, yung mga pag-anggulo natin, yung mga kuha natin ng larawan, no, ng mga litrato. We can also apply mathematics. Syempre, in reality, we use perspectivities, no, as we have discussed in projective geometry. But ideally, di ba sa Instagram, I do not know kung meron pa rin yun ngayon. But before, pag nagpipicture tayo sa Instagram, meron yung grids, di ba? Which follow the rule of thirds. And aside from that, so kunyari dito, yung pag-angulo, no, nung pagkakakuha ng picture na ito, is wherein we can actually create a golden spiral starting from the head of this little girl. No? So we have a golden spiral here, which means that this actual photo follows the golden ratio. Diba? Kasi we can create or we can form a golden spiral in it. Okay? And then in the new media, so this is an example. So during the 2016 State of the Nation address, this was actually the first State of the Nation address, or SONA of President Duterte. I think the director was Brillante Mendoza. And if you can see, one of the frames actually follow the golden ratio, kung saan inanggulo yung camera in such a way that the golden spiral will start from the head or from the face of President Duterte. Okay, so aesthetically, this is pleasing, no, to the eyes because this follows the golden ratio. Okay? Okay po ba? May tanong po? Questions? So, the director, no, was really brilliant, no, in doing so. No, even the lighting, of course, the lighting has effects, no, but if you look at it, this frame, this one instance of the SONA follow the golden ratio. Okay, thank you, Eileen, Zarina, Adrian, James, and Piolo. All right. So here are some other influences of mathematics in the art. So we have the Last Supper. Napag-usapan na natin ito, no, when we talked about projective geometry, diba? So again, this was Leonardo da Vinci's work, and of course, this follows perspectivities. No? So sabi nga natin, since the center or the focus of the the focus of the Last Supper should be the Christ. The perspectivities or the lines in the painting are all pointing towards the Christ. Okay, so that's how Da Vinci wanted to focus towards the Christ, no, in this painting. Okay, so nung pinag-aralan natin projective geom, pinakita natin yung outline, di ba? Yung outline ng painting na ito. And in fact, aside from the vanishing point, we can see that the lines are all pointing towards the Christ, no? Being the center and the focus of the Last Supper. Okay? So that's it. And then I cannot recall if we already talked about this, the Great Wave of Kanagawa. So if we look at it, kung mapapansin natin, so we have a big wave here. And then at the end of the waves, hindi siya ending talaga, no? There are smaller waves, and that is what we call as an illustration of a fractal. Kasi pag sinabi nating fractal, anywhere you zoom into the picture or into that figure, you will be seeing the same thing as the whole. Okay, so kahit sa maliliit na parts, makikita mo yung mismong isang malaking part pa rin. Okay? So that's the idea of a fractal. And then although it's a new field or a new subfield of geometry, kasi nga dati hindi na appreciate masyado yung idea of a fractal, no, kasi hindi naman siya masyadong na-visualize, no. But during the digital revolution, no, since we can already now graph, no, even the hardest of our equations, we can now visualize what a fractal really is, no. At interesting yung mga figures, yung mga graphs na makukuha natin from these fractals. So kung makikita natin, actually ang tanong nga dito, nung bang ipininta ito nung artist, this was painted by a Japanese artist, if I'm not mistaken. Nung bang ipininta niya to, may idea na siya kung ano yung fractal o it's an actual observation. But of course, if we really look at the waves, we can see smaller waves at the end of the waves. And those smaller waves also have smaller waves, di ba? So, paulit-ulit lang siya. So, it's an example of a fractal. Okay? And if you are familiar with the movie Frozen, di ba? Yung Frozen 1, yung sikat na kanta doon ay yung Let It Go. So, how did they describe a snowflake? Diba sabi dun, it's a frozen fractal. Because if you actually zoom in a part of the snowflake, it's as if you are looking at the entire snowflake pa rin. Diba? So, paulit-ulit lang yung figures na makikita mo sa isang snowflake. So, pare-pareho lang sila. And that's an example of a fractal. Okay? So, ganun po kapag sinasabi natin fractal. And that has something to do not only, that has an essence. No? Kunyari, yung venation ng plants, later we'll have a discussion on that. Meron din kahalagahan dun sa plants yun. No? The way that the food and the water is being distributed, of course, the arrangement or the venation has something to do with it also. Okay, so may mga kahalagahan yung mga bagay na yan. Hindi lang siya pampaganda doon sa itsura ng mga halaman, ng waves, and so on and so forth. Okay? So these are just some other examples, no, of where we can find mathematics in artworks. Okay? Clear po ba? Are we clear? Okay, thank you, Piolo, Zarina, Adrian. How about the others? Yan, mga sukit po yan. Thank you. How about the others? May tanong po ba? Are we clear? Thank you, Patricia and Eileen. All right. And James. Okay, so mathematically speaking, symmetry is one important. No? So one important concept. It's one of the fundamental objects that we study in mathematics. And when we talk about symmetry, we need also to talk about isometry. So what really preserves the distance and therefore the shapes of the objects. So kapag sinabi natin isometry, these are transformations na kung saan kapag ginalaw natin ang isang bagay, no? So when we anong tawag dito? When we use or when we apply a transformation in a figure, kapag nape-preserve yung kanyang shape, so if the shape does not change after the application of the transformation, we say that the transformation is an isometry. Okay, so dapat hindi nag-iiba, no? The distances of the lines in the figure should still be the same, and therefore the shape of that figure should still be the same. Okay, so that's an isometry. And here are the four. So these are the shape, the distance, and therefore the shape preserving transformations. So we have the translation. So kapag translation, inuusod lang natin. No? We are just moving at a fixed distance in a fixed direction. Okay, so halimbawa, this triangle here, when we move it to the right, like this is now the triangle, which is the same. No? This is the exact triangle as before. Yun lang, nausod lang siya ng konti. So this is translation, and it also preserves the distance. And then we have the reflection. So sa reflection, no, we just get the mirror image. So ang mahalaga dito, yung axis of reflection. So saan ba tayo nagre-reflect? Because different axis of reflection means a different reflection. Diba? So halimbawa, if this is our triangle and we reflect along this vertical axis here, our image will be something like this, di ba? Ito na yung magiging mirror reflection niya. Okay, but if we get an axis of reflection at the bottom, then iba naman yung magiging mirror reflection niya. But iba naman yung magiging reflection niya. Iba yung magiging output natin. But the idea is that the reflection will be of the same shape, no, with the original. Okay? Kaya siya isometry. Kasi nire-reflect mo lang. So the image, although the orientation will be different, the image will technically be just the same image. Okay? So, parang siya din yun. Iba lang yung orientation, pero siya pa rin yun. Okay? Pero syempre, yung mga axis of reflection, so we can consider a diagonal axis of reflection. We can consider na what if yung ating axis ay nasa loob nung figure. Paano kung vertical tapos dumadaan dun sa mismong triangle? So syempre mag-iiba din yung image niya naman ngayon, no? But we'll not deal with that anymore. Okay? So that's reflection. We also have rotation. So sa rotation naman, dalawa yung mahalaga. We have the we have the center of the rotation, and we have the angle in which we rotate. Diba? So, pag nag-iba yung center of rotation mo o nag-iba yung angle kung saan tayo nagro-rotate, mag-iiba din yung itsura ng output. But again, the shape will still be preserved. No? Dahil nga, inikot mo lang, di ba? Ni-rotate mo lang. But the shape, the distances will still be the same. Okay, so halimbawa, this triangle here, if we rotate it, kunyari, this is our axis, this is our center of rotation, and we would like to have this rotated at 90 degrees, kunyari, then this will be the image. Pero kung kunyari, ito yung center mo, nasa loob, tapos you rotate counterclockwise 90 degrees, iba din yung image mo. But technically, the shape will still be this triangle itself. Okay? Again, nag-iiba lang yung orientation. Okay? And then we have what we call as the glide reflection. So sa glide reflection naman, is a combination of translation and reflection. Kaya nga siya glide reflection. Kasi you glide, you translate, and then you do reflection. You reflect. Okay? So halimbawa, this triangle here, you translate going to the right, and then you reflect along this axis, this will be the image. Okay, so you glide, you glide and then you reflect, or you translate and then you reflect. Okay, so it depends again, no, since meron na siyang reflection, it depends on the axis of reflection and the direction in which you translate. Okay, so these are the 4 types of isometry. But with again, no, in all of these transformations, this shape is preserved. No? The shape of the figure is still being preserved. Okay, questions with isometries? Questions po? Thank you. Thank you, James, Piolo, Zarina, Adrian, and Eileen. Okay. Now, with these isometries in mind, with these isometries in mind, we have what we call as a symmetric patterns, and these patterns are are being determined by the number of the linear directions involved. Okay? So kung walang, kunyari, we have a certain motif, we have a design, and to create a pattern, di ba, we need to replicate that design. Okay? We need to replicate that motif. So if we replicate the motif in no linear direction, ibig sabihin hindi linear yung ating pag-uulit doon sa ating design, we call that as a rosette pattern. Okay? So kung isang linear direction lang, kunyari, meron kang isang design, tapos inulit mo siya ng going to the right or downwards or upwards or going northeastwards, ayan. Kapag isa lang yung direction na papuntahan niya, one linear direction only, we call that as a freeze pattern. Later we'll have we'll have examples. And finally, no, if we have multiple linear directions involved, so when we replicate our designs in multiple linear directions, we call that as a wallpaper pattern. Okay, so kapag combination na siya nung pataas, pababa, diagonal, or going to the right, going to the left, and so on and so forth, if it's already a combination of these linear directions, we call that as a wallpaper pattern now. Okay? So for the rosette pattern, as we have discussed, we have no linear direction involved. So for instance, dito sa pattern na ito, ano yung motif na umuulit-ulit? So we can take this part, kunyari, diba? Itong part na ito. So para makagawa tayo ng pattern, para mabuo natin itong pattern na ito, what we do is to replicate this motif or this design in a circular manner, di ba? So there will be no linear direction involved. No? Dahil nga yung ating pag-ulit ay in a circular manner. Meaning, we involve rotation. Di ba? So niro-rotate lang natin. So we can think of it being rotated counterclockwise or clockwise, no? So in any way that you want, no? Basta paikot siya. So we can think of it that we have this design here, and then we rotate, kunyari, clockwise. Ilan to? 30 degrees siguro ito, no? 30 degrees. And then this is the center until you get this entire pattern. But the question is that, will there be a reflection involved? Ibig sabihin, will there be an axis in which I can cut across the image such that there will be such that one part will be a reflection of the other? Okay, so kapag ba naghati ako, at some point, yung isang part ba ay magiging kamukha lang din ng isang part. So if that is the case, we say that the pattern dihedral rosette pattern. Okay, dihedral kasi may reflection involved. No? We can divide it into equal parts. No? So this is the dihedral. And this classification was was made by Leonardo da Vinci. Okay? So, kapag may, halimbawa, dito sa pattern na ito, kung hatiin ko siya dito, no, vertically in the middle, the left side will be exactly the same with the right side. Di ba? Reflection-wise. So, parang ito yung magiging mirror of reflection ko, and this side will be the image of the other side and vice versa. Okay, so in that sense, we say that this pattern is a dihedral rosette. Okay? Okay? Okay po ba? Okay? Okay po. Thank you, Adrian, Piolo, James. Yung iba po, okay po ba tayo? Are we still good? Okay. Okay. Now, kapag walang reflection involved, we call that a cyclic, no? Parang cycle lang siya. So, dahil nga umuulit lang siya, pero walang reflection involved, we just form a cycle. Okay? So, we call it as a cyclic rosette pattern. So, for instance, this pattern here, the initial or the original design is just a leaf, di ba? So, isang dahon lang. And then we can think of it that we are just rotating it counterclockwise. Yeah, counterclockwise, maybe 30 or 45 degrees siguro. Rotating at the center, with respect to the center at 45 degrees, counterclockwise, we can get this rosette pattern. But, parang kung isipin natin, wala tayong pwedeng paghatian in such a way that we will get equal parts. Diba? Kunya, hinati ko siya sa gitna. O kahit hatiin ko siya diagonally, yung isa ay hindi mirror image ng kabila. Okay? So, in that sense, we say that this is just a cyclic rosette pattern. So, dalawa lang yan. We have the dihedral and the cyclic rosette. Okay? So, again, kapag merong reflection, if one is a mirror image of the other, if one part is a mirror image of the other, we say that it's dihedral. Otherwise, we say it's cyclic. Now, let's have this rosette table mantle. So, which kind or what kind of rosette is this? So, syempre, rosette yan. Malinaw naman, no? Kasi walang walang linear direction, no? So if you get a design, if you get a motif here, para mabuo mo itong table mantle na to, circular, no? So circular yung gagawin mo. So there will be no linear direction, no? Linear direction, no? In the replication of the image or the design. So this will be indeed a rosette pattern. But what kind of rosette? Sige, I'll be waiting for your answers. Is this a cyclic or is this a dihedral rosette? So remember, kapag dihedral, dapat merong reflection. No? Meron tayong makikitang mirror image of one another. So if not, we say that it's cyclic. Sige nga, is this dihedral or rosette? Anyone? Nandiyan pa ba kayo? Sabi ni Eileen, dihedral. Sabi ni James, dihedral din. How about the others? Okay, yes, this is dihedral, no? Kasi if you look at it across, kunyari vertically, kunyari this part here, this side will be the mirror image of this side, no? And vice versa. Actually, kahit na pa-diagonal, kahit na horizontal, no? Yung iyong paghati, one part will be the reflection of the other, no? So this is indeed a dihedral rosette. Okay? Now, we have the freeze pattern. So sabi natin kapag freeze pattern, meron tayong one linear direction. So it's either you go to the right or you go downwards, or you just one linear direction to replicate the image, or to reproduce the image or the design that we are interested in. So we have 7 types of freeze patterns. So we have the the hop pattern. So para siyang isipin natin na lumulundag ba? Ano bang hop? Kumakandirit yata. So hop. So we have 1 foot here, and then to replicate, we move to the right. Diba? So dito sa image na to, we move to the right to replicate the image. We just translate. So there is just translation involved of the 1 foot. So that's why we have here a hop freeze pattern. Kasi isa lang yung direction natin. Papunta lang sa kanan, o pwede mong isipin na papunta sa kaliwa, yung paa mismo. Okay? And then we have the step freeze pattern. So lahat naman ito ay papunta rin ng one direction lang to, na parang yung banda. Joke lang. So this is just one direction, one linear direction. So sa step naman, ang pinagkaiba niya, there will be a reflection involved, because if you look at it, we have this foot here, and then to get the other side or the other foot, we reflect towards this horizontal axis here, this imaginary horizontal axis of reflection. And then we translate a little. Kaya siya step, kasi parang naglalakad ka lang. So imagine you have this foot, and then this foot, and then you step forward, and so on and so forth. But talking about isometries, we have this foot here, and then we reflect, and then we glide a little, or we translate a little. So the reflection involved. So purely glide reflection for this step freeze pattern. Okay? And then for the jump pattern, so dahil nga tumatalon ka, magkapantay yung mga paa. So this is just this is purely reflection, and then translate, reflect, translate, reflect, translate. Okay? So ulit-ulit lang yung image na nakukuha natin. And this goes to just one single linear direction, which is going to the right, or going forward, moving forward, kung tumatalon talaga, if we think of it that we are actually jumping here. Okay? Then we have the seedle. So sa seedle naman, parang ano nga yun? Para siyang nagpapadaus-dus ba? Yung tamang term. But if we look at it, we have this foot here, we reflect, and then we reflect, we reflect, we reflect, we reflect. Okay? So the axis is always a vertical axis, doon sa tabi ng paa. So reflect, and then you reflect, you reflect. Okay? So that's the seedle. And again, it's just towards one direction, going to the right. And then we have the dizzy hop. So ang kinaiba lang ni dizzy hop, may rotation ka, kasi if this is the foot that we consider to get the other foot, we reflect along the center. So this will be the center. So, we rotate pala with respect to the center. Okay? So 180 degrees. You get this foot, and then para makuha naman yung kabilang paa, you rotate again. Okay? Along the center, 180 degrees. And so on and so forth. Okay? So that will be a dizzy hop. And then we have the dizzy jump. So kaya siya dizzy hop kasi, di ba, kumakandirit ka pero paikot-ikot. Mahihilo ka talaga siya. And then we have the dizzy jump. So dito naman, tumatalon pero pabaliktad, So you are jumping while rotating 180 degrees. So paano nakuha si dizzy jump? We reflect along this axis, and then we reflect dito naman sa vertical axis. And then we reflect towards the horizontal axis para makuha, and so on and so forth. Okay? So this is the dizzy jump freeze. And then we have the dizzy seedle. So dito naman, reflect, rotate. Diba? Reflect, rotate, and then reflect again, and then you rotate, and then you reflect. Okay? Malinaw po ba? Malinaw po ba sa atin yung mga freeze patterns? So what's important here is that the freeze patterns are moving towards one linear direction only. Okay? Thank you, Piolo and James. All right. And Aileen. So here are some examples of freeze patterns that we can find in cloth. So, kung mahilig tayo dun sa mga, tama ba yung ethnic na tawag? Ethnic designs, most of the time, they are using freeze patterns. No? So, linear direction lang siya. So, for instance, this design here, paano siya na kuha? So, starting from this motif, you just translate. So, just translate, and then this two here, you translate, no? You replicate by translating into one direction going to the right. Pero dito naman, iba, no? So, this is your motif. So, what you do is to rotate. Rotate, and then you rotate again, and then you rotate, and so on and so forth. Okay? So, these are examples of freeze patterns, which we can find in cloth designs. Okay? And then we have the wallpaper pattern. So there are 17 wallpaper groups. So kapag sinabi natin wallpaper, it's a combination. We reproduce the design or the motif in multiple linear directions. So ano siya? Combination, no? Combination ng pwedeng pataas, papunta sa kanan, diagonal, no? And so on and so forth. So these are the 17 types of wallpaper groups that we will not talk about them anymore. Ang mahalaga lang naman sila ay combination. So kung makita mo dito, meron tayong pa-diagonal, tapos diagonally going to the right, dito naman diagonally going to the left. No? Tapos ito pwede mo ring isipin na going to the right. So there are indeed multiple linear directions, no, in which we reproduce the design. Okay? So that's the wallpaper pattern. So in this example here, so the tilings, no, is a wallpaper pattern, because if you look at it, the design, we can think of the design going to this direction, or we can think na going to this direction also, and also pwede namang diagonal din. So since we produce the pattern in multiple linear directions, we say that this is a wallpaper pattern, no, for the tilings. Okay? Questions? May tanong po ba before we proceed to the next part of our discussion? Tanong po? Tanong? Thank you, Adrian, Eileen, and James. All right. Okay, so for this part of the lesson, no, there, of course, we have a corresponding formative assessment as usual, no, for this topic. But for this part of the lesson, no, the task is for you to look for an artistic masterpiece or even a design, and discuss the mathematics used or can be observed in it. So pwedeng painting, you can look for a painting, you can look for a picture, you can look for a sculpture, so pwede yun, no? And you talk about the mathematics which was used, or the mathematical concepts that you can observe, no, in that artistic work. Okay? And then another task is for you to look for a pattern in your household. So, anong mga patterns ba yung nakikita natin sa paligid? Yung example kanina, yung mantel. Di ba yung ating mga table mantels? Tama ba? Most of the time, they are rosette. Minsan hindi rin, no? But you can look for other designs and just classify, no? Just tell us what type of pattern was it. No? Is it a rosette? Kung rosette, anong klaseng rosette? Is it dihedral or is it cyclic rosette? Kung frieze, anong type of frieze naman, no? Or if it's is it a wallpaper pattern? Okay? And then yung pinaka highlight siguro ng activity is for you to create your own design by applying isometry. So you can think of any design. Actually, you can get a design from the internet, but you should be the one to apply the isometries, ha? The problem I encountered with your formative assessments for geometry was that, although hindi ko pa tapos checkan lahat, hopefully I will be finished by the end of this week so that you can know your current standing, no, after the 3 modules or the 2 parts of the semester that we already went through. Now, going back, the problem I encountered was that there were some students who copied and pasted the exact answers from the internet. Now, although I do not have problems, I do not have problems that you are checking the internet for, kunyari, you will take pictures, you will get images from the internet. What I do not like is that you are just getting the answers, the exact answers from the internet. So, pwede naman, kunyari, for this task, kuha tayo ng isang design, kunyari, picture ni Captain America, and you want to create a design or a pattern using that, you should be the one to create the design, okay? Using the picture of, kunyari, Captain America nga. Okay? So, ganun po. I hope that you do not just get a pattern from the internet, no? So, a picture from the internet. No? So, that will be your loss. Okay? So, ganun lang yun. Okay? So, I hope we are clear with that, no? And that's the first part of our discussion today. So, clear po ba yung mga gagawin for the activity? Kasi karamihan dun sa formative assessment na nag-grade ko ay exact answers, no? Yung nakuha from the internet. So, kung ano yung sagot mismo sa tanong, yun mismo yung nilalagay ninyo. Okay? So, are we clear? Or are we not? Thank you, Eileen. How about the others? Piolo and James, thank you. Okay. Yung iba po, malinaw po ba? Okay, kung wala pong tanong, let me just share the other part of the discussion. Hindi ko siya mapag-merge, no, into one single file. I think nagkakaproblema with the design of the presentation. Kala mo naman kagandahan yung designs. Pero anyway, okay, so let me just share the other presentation that we will discuss today. So this will be the mathematics in the life sciences. So we'll just look around us, as I have said. We look at the surroundings. We look at our surroundings, and then we try to find mathematical concepts in them. Okay? So nakikita na po ba ulit yung slides natin na bago? Can you see the slides now? Kita na po ba? Are the slides visible now? Thank you, Piolo. Okay. So, sabi natin kanina, no, yung golden ratio is a non-repeating, non-terminating decimal, approximately 1.6180, and denoted by the Greek letter phi. And we also have what we call as the Fibonacci sequence, coined or credited to Leonardo Fibonacci. So most of the time we are referring to him as Fibonacci, but in some texts you can see we refer to him as Leonardo of Pisa, minsan Leonardo Bonacci, no, kasi yung Fibonacci ang ibig sabihin daw ay Italian kasi siya, no, so ang ibig sabihin daw ay Phi, the son of, no? So Fibonacci meaning the son of Bonacci, ibig sabihin galing siya sa pamilya ng mga Bonacci, no? So kaya Fibonacci. And Fibonacci was a merchant, so ano siya, nakikipag-barter siya, so traveler din siya, so sana all nakapag-travel pa rin. But ayan, yan si Leonardo Fibonacci, and we are familiar with his Fibonacci sequence. Now, sa Fibonacci sequence, we always start with 2 1s, so 1 1, and then to get the next term of the sequence, we simply add the two preceding terms. No? So for the third term, we add the two preceding terms, which is 1 and 1, so we get 2. And then to get the next term, we add the two preceding terms, 1 and 2, so we get 3. And then para makuha mo yung next term, we add 2 and 3, so we get 5. Tapos para makuha yung sunod, we add 3 and 5, we get 8. And then 8 plus 5 is 13. 13 plus 8 is 21. And then 13 plus 21 is 34. And so on and so forth. So what will be the next term after 34? Sige nga, Let me check if you know the Fibonacci sequence. What will be the next term after 34? So 34, and then we have 55. Yan, tama si Piolo. Thank you, Piolo and Zarina and James. Ayan. So that will be 55 kasi di ba we have 21 plus 34. Okay? And in fact, if you check, the ratio between the two numbers are approximating the, thank you rin Adrian, the ratio between any two given terms of the two consecutive terms of the Fibonacci sequence approximate the golden ratio, 1.6180. So kung titingnan natin, kunyari isa-isahin natin, syempre yung 1 divided by 1, that will be 1, and then 2 divided by 1, so the larger number divided by the smaller number. So 2 divided by 1 will be 2, and then 3 divided by 2 will be 1.5, and then 5 divided by 3 will be 1.66667, no? And then 8 divided by 5 will be 1.6, and then 13 divided by 8 will be 1.625, and then 21 divided by 13 is 1.6153. So kung mapapansin natin, lumalapit tayo, no? Palapit ng palapit doon sa value ng phi, no? Sa value ng golden ratio. And then we have 34 divided by 21 is 1.6190. So mas malapit na siya lalo because the value, no, or the approximate value of the golden ratio is 1.6180. Okay, but 34 divided by 21 is 1.6190 approximately. Okay, so kung mapansin natin, as we move towards the larger terms of the Fibonacci sequence, we are actually getting ratios which are closer and closer to the value of the golden ratio or the value of phi. Okay? Now, with that in mind, saan ba natin makikita ang golden ratio at Fibonacci sequence? So sabi natin kanina, kapag sinabi natin or when we say that figures or things are following or are proportioned using the golden ratio, they are mathematically beautiful, no, or aesthetically pleasing. So in fact, we are all aesthetically, mathematically beautiful, no? Because in fact, our body parts are proportioned in such a way that they approximate, or the ratio approximate the golden ratio. Okay? So, sa totoo lang, we are all beautiful, no? So, kung sa regular classroom setup, what we do here is to just, so mas maganda kung may mga ruler tayo, no? Kasi we will be measuring our body parts and then, or meter stick. So, in the usual classroom setup, what we do is to look for the golden ratios. But of course, hindi siya accurate, no? Hindi siya exactly the golden ratio, but we are getting something, or the ratio that we get are very much close to the value of phi, no, or the golden ratio. Okay, so indeed, we are all mathematically and aesthetically beautiful. Do you agree with that? Naniniwala ba tayo dun? So, naniniwala po ba tayo dun? In the usual classroom setup, ang ginagawa namin, nagsusukatan kami, tapos nagpapalapitan lang kami. So we look for we look for whose measurements are closest to the golden ratio, but everyone's measurements are close to the golden ratio. Okay? So kumbaga nagpapagandahan lang, pero lahat ay maganda. Okay? So naniniwala ba tayo doon? Do you agree with that? Do you agree or not? Yes. Thank you, James. So, dapat maniwala tayo dun, no? So, mathematically pala, lahat tayo ay magaganda. Diba? So, lahat tayo ay winner. So, yon. And with that, no, so here are some, that's a mathematical fact naman. So, since we are, by definition, no, our measurements are close, no, to that of the golden ratio. And here are some parts, no, of our body, no, whose ratios are approximating the golden ratio. So in the face, pag sinukat daw natin yung from the crown of our head to the to the ang tawag dito, to the chin, no, sa ilalim ng baba, and then we get its ratio over the width of our face, we get an approximation to the golden ratio. Okay, so sa body naman, so our height divided by the measurement of our lower extremities, no? So from the waist to the sole of our foot, we get again something which is close to the golden ratio. Okay, so kunyari shoulder to the fingertip, and then shoulder over shoulder, the measurement of the shoulder to the elbow, we get again something which is an approximation to the golden ratio. Okay? Pero hindi lang naman unique sa tao ang golden ratio. Even in the animals, we can find golden ratio, so sa mga langgam. So kahit dito, no, actually yung bahay ng mga snail, no, they are casing. Anong tamang term dun? So the casing, quote unquote, the casing of the snails, no, we can actually form a golden spiral in there. Tapos sa ants, no, meron ding mga golden ratio dyan with their parts. And then the width, no, the height and the width of the wings of the butterfly, and even the, I do not know the biological term for that, but the quote unquote designs dun sa mga pakpak ng mga paru-paro ay may golden ratio din doon, even in the parts of this penguin. Okay, so in animal forms, no, we have we can also observe golden ratio. And now for the petals, for the plant arrangements, so what's interesting is that they are the numbers and even the arrangement of the petals follow the Fibonacci sequence. In what way? So kung titingnan natin itong petals, itong flower na ito, yung petals niya ay ilan? 2, 4, 6, 8. So we have 8 petals, which is actually a number or a term in the Fibonacci sequence. Pero baka sabihin nyo, nagkataon lang. Nataon lang po yun. No? So if we look again at this sunflower here, the number of the petals is 21. So again, this is a number or a term in the Fibonacci sequence. So in fact, the number of petals are close, no, really close to terms of the Fibonacci sequence. No? But most of the time, they are indeed terms, no, or numbers in the Fibonacci sequence. Pero kung hindi man, malapit. Okay? And then dito, no, in the arrangement of the petals of this rose, so syempre kung mapapansin natin yung mga rosas, di ba, meron siyang inner petals, tapos outer petals, and then the outermost petals. So for instance, in this figure or in this image here, yung inner petals, yung arrangement niya ay mayroong 8 petals. Di ba? So that's a term in the Fibonacci sequence. And then, yung outer niya ay 1, 2, 3, 4, 5. So again, a term in the Fibonacci sequence, and so on and so forth. Okay? So hindi lang yon. If we look closer to the sunflower, so kung ano yung tawag natin dito, yung pinakagitna niya, yung kasi budbud yung tawag ng mga ano dyan, no, yung matatanda. Yung budbud ng sunflower, the pollen. Sorry, I'm not knowledgeable with these biological terms, but yun nga, yung arrangement of this pollen, the middle part of the sunflower. So ito, yung going upwards to the right, 55, and the ones going upwards to the left is 34. So both of them are again numbers or terms in the Fibonacci sequence. Now, sa mga prutas naman, so pag hinati natin yung isang mansanas, no, if we cut an apple, we see or we can observe that it has 5 cross sections, no? And again, 5 is a number or a term in the Fibonacci sequence. Tapos ito kunyari yung pear or even the bananas, no? So sa banana naman, sa saging, 3 yung cross sections niya. So if you cut a cross section of a banana, you will see three cross sections. And again, this is a term in the Fibonacci sequence. Okay? Saan pa? Yan, sa radial array of the web. So in fact, if you look at the distances, di ba, ang perfect nung ano to? Nung distances in between, di ba, the web of the spiders or the spider webs. And sabi nung sabi nila the web of the spiders follow the or approximate the golden ratio. Okay? Yung distances, yung measurements, it follows the golden ratio. But more than that, the number of the radial arrays are close, if not exactly, a term of the Fibonacci sequence. Kung bibilangin mo to, 34 yata ito. No? So there are 34 radial arrays. And that's again, so yung mga paganito, no? And that's again, a term in the Fibonacci sequence. Now, sa plant branching, so if we think of it like we are cutting a plant or a tree, and we look at how the branches are arranged, then we can actually see or we can actually observe the Fibonacci sequence itself. Okay? So, paano yun? We have here, kunyari, hinati natin sa ganito. So, for this part, we have one branch, and then this part, we have another branch. And then for this part, we have how many branches? 1, 2. And then for this branch, we have 1, 2, 3 branches. And then for this branch, for this part, we have 1, 2, 3, 4, 5 branches. And then for this part, we have 1, 2, 3, 4, 5, 6, 7, 8. And finally, for the topmost part, we have 13 flowers and 13 branches with flowers. And in fact, that's the sequence, di ba? That's the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, and so on and so forth. So in fact, the branching of our plants follow the Fibonacci sequence also. Okay? Pero siguro ang interesting dyan, yung Fibonacci sequence ay inaral ni Leonardo of Pisa or Leonardo Fibonacci to study the reproduction of the rabbits. No, kaya lang naman nabuo yung Fibonacci sequence kasi inaral niya kung gaano karaming rabbits yung maipapanganak, no, given that you have an initial pair of rabbits, and then those rabbits will be reproducing after every month starting at the 3rd month. Ay kaya siya, kung makikita natin, balikan lang natin yung sequence. So for the first month, you have one pair. Tapos hindi pa agad, syempre may getting to know each other stage pa daw yung rabbits, no, sabi ni Fibonacci. So after that month, you get one pair of rabbits pa din. Okay, but at the second month, at the end of the second month, no, so it's a scientific fact, no, that rabbits reproduce or conceives at most 31 days. No? So after a month, at the 3rd month, magiging dalawa na yung pairs, no? Pero yung bagong panganak na pair, hindi pa agad yun magkaka-baby, no? So after ng susunod na buwan pa ulit. No? Pero yung original na pair ay patuloy-tuloy nang magkakaroon ng babies after each month. Okay? So kaya nabuo yung Fibonacci sequence. No? Chika lang naman yun. But going back, so again, the branching of the plants or the trees are also following the Fibonacci sequence itself. Now, we also have symmetries. So kanina inaral natin yung symmetries. So in the nature, no, so we have some symmetries that we are very much familiar with. So the radial symmetry. So syempre sa starfish, sa jellyfish, radial yan. So kung ito yung iyong kukuhaning cross section o yung kukuhanin mong section to get the entire, no, yung symmetry mo ay from a fixed center, no, kaya siya radial. So ganun din sa jellyfish. And then we have this stripe pattern symmetry. So for this snake, so most commonly sa reptiles, no, yung stripe pattern, we have kunyari orange, yellow, black, yellow. So, orange, yellow, black, yellow. So, for the snakes. Dito sa snake na to naman, black, then, ano ba to? Cream, and then black, and then brown. So, ganun ulit. So, paulit-ulit lang yun. No? So, that's what we call as the stripe pattern symmetry. Then we have the bilateral symmetry. So sa atin naman, no, sa mga tao, bilateral din tayo. So what the left side is almost the same. We are considered symmetric with respect to the ano to? Ang acting axis of reflection ay yung gitna. No? So we are bilaterally symmetric. So ganun sa mga seashells, no, sa oysters, mussels, no? And then dito sa ano nga to? Dito sa tiger, no? So sa atin, no, sa mammals, we are also bilaterally symmetric. Then even sa insects, no? So mapapansin natin yung mga insects, kung ano yung kaliwa, yun din yung kanan. So that's what we mean by bilateral symmetry. Okay? Questions so far? Questions po before we proceed? Gising ba tayo? Thank you, Piolo and James. Ayan, I hope you are still awake. We are almost there. We're almost in the end. Okay, so even the virus, no? Even the viruses have their own symmetries. So although obvious, no? Pero meron silang symmetries, and even this COVID-19, di ba, inaaral natin yung structure. Sorry, we study the structure. Kung napanood nyo yung ano ang series yun sa Netflix, yung about COVID-19, ayan, they are studying the structure of the virus, and in fact, the viruses are also symmetric. But there are several kinds, no, of symmetries in a virus. And yun, we are using this structure, no, to know the type and how are we going to conquer, no, to fight these viruses. Okay? So, kung wala pong tanong, that's the end of our discussion. And here are some tasks, no, for you to accomplish. So for this part of this discussion, you look for at least 2 natural elements. So ibig sabihin lang your surroundings, no? Halaman, ganyan. I do not know the biological term for that, but you look for something natural, no? Something in nature, no, in your household. And briefly discuss the mathematical concepts that you observed in them. So that will be a part of the formative assessment, no, for this. And then we have a supplemental video which is already posted in Canva. So Math, Symmetry, and Our World. Again, this is academician Jose Maria Balmaceda, no, and produced by UP Talks. Okay? Okay po ba? Okay. Malinaw po ba lahat so far? Yung iba po. Thank you, Piolo, James, Adrian. Yung iba, okay pa ba tayo?
Sir,
Yes.
question lang po. Sir, sinama niyo na po ba yan sa FA 4.1? Ito
Oo.
pong task po na to?
Yes, oo. Bali yung FA 4.1, 4 na items yun. No? The 3 will be coming from the mathematics in the arts. Tapos yung isa ito. Yung look for at least 2 elements. Kasama na yan. Yan din yun.
Sir.
Sure.
Natanong ko lang po kasi tinignan ko po yung FA 4.2. Akala ko po FA 4.2 po yan. So,
4.1. Oo, kasi di ba nag-skip tayo, nag-deviate tayo from the syllabus last meeting. Di ba? Yung last meeting, 4.2 yon. Tapos ito yung 4.1. Bale.
Okay po, sir. Thank you po.
Okay. Salamat din. Now, thank you for that clarification. As we have discussed last meeting, so we are now in the concluding parts of the course, no? And if you observe, so sabi ko nga kanina, this will be the last discussion day that we will have. But there will be one remaining lesson which we are leaving as a reading assignment. So sabi ko nga, itong lesson natin, no, on mathematics in everyday life, we just need to browse, no, through the mathematical concepts that we are actually applying in our everyday lives and which we will be using, no, or pwede nating isipin na ano nga ba yung mga concepts na pwede pala nating gamitin pa sa pang-araw-araw nating buhay. So it's an easy read, it's an easy lesson, no, for us to understand. And like with the other lessons, it has a corresponding formative assessment. It's a short essay on the topics that we are, or on the mathematical ideas, no, and concepts that we are applying and we will be applying in our everyday life. So ideally, we are doing this on Friday. So we'll be having an asynchronous activity on Friday. But since everything is already uploaded in Canvas, as I said, you can already access, no, the file. So you can already read, no, and work on the corresponding formative assessment. Okay? But ideally, we use our time on Friday to asynchronously study. Okay? Asynchronously learn this lesson. Okay? And then we also have a supplemental video on mathematical modeling. So again, by academician Balmaceda. And this talks about how we forecast, how we predict, no, using mathematics. Parang paano nalaman o paano nasasabi ng Pag-asa that it's possible that we have 3 more typhoons to come this year, no, before we end the year. So paano nila yung nasasabi? And that is something about the mathematics of predictions. So sabi nga nila, mathematics is the study of patterns and we are using these patterns for predictions, okay? For our wise guess. Okay? So that will be a supplemental video, but I believe that in this time of a pandemic, it's more appropriate for us, no, to learn how we do the mathematical modeling of the pandemic of COVID-19. And though you are not required, no, to join the webinar on December 4, that will be Friday at 10:30 a.m. So you are not required to join, but I suggest, no, I really recommend that you participate in this webinar so that we will have a grasp, no, of how are we applying mathematics. Sabi ko nga, it's a good example, no, of how we apply math in this time of a pandemic. No? Kasi yung supplemental video natin is about calamities. It's about typhoons, it's about landslides, and so on and so forth. But in this time of a pandemic, no, that will be the COVID-19 pandemic will be the topic, no, will be the focus of the discussion of the webinar by Dr. David. Okay, so that will be on Friday at 10:30 a.m. And I think some already registered. Sabi kanina, may mga nag-register na. So I thank you for that. But if you are not available and you still want to watch the video, I think this will be streamed live in FEU page, no, which you can visit later. Siguro kung hindi kayo available at 10:30. But I strongly suggest that you join us in this webinar. Okay? All right. Okay. So on December 11, so again, we will not have a meeting on December 4, no, but the idea is for us to study asynchronously the lesson and work on the formative assessments for mathematics in everyday life. Okay? And then December 11, so December 8, I think it's a holiday. So December 11, that will be next Friday. So the Friday next week, we will allot that for you to work on your, we will not have a virtual discussion anymore, but December 11 will be allotted and dedicated for you to work on your final project. Sorry. So again, the final project is an infographic of the mathematical concepts that you are applying now in your areas of specialization, in your fields of in your accountancy, in medbio, no, kung meron. So, ano-ano yung mga math na ginagamit ninyo? And what will be the mathematical concepts that you will be applying soon, no, in your field of specialization, in your profession. Okay? So, yun yung idea ng inyong infographic, ng inyong final project. May tanong po ba? Questions with the final project? Anyway, that will be on December 11 and we are allotting that as a consultation, but of course you know that you can ask question anytime. You know that I even reply at the wee hours of the night, no, kung gising pa tayo. But ayan, so ideally we will have a consultation on December 11 if really necessary, but as mentioned, you can always just message an email away. So you can always reach me, no, through my email or even through Canvas. Okay? And then on December 15 at 5 p.m., that will be the last day for you to submit the outputs for Module 4. So si Formative Assessment 4.1, ito yung diniscuss natin ngayon. 4.2, yung diniscuss natin last week. And F8 4.3, the one corresponding to the asynchronous activity, no? The mathematics in everyday life, together with your final project, the infographic. They are all due on December 15 at 5 p.m. So most probably hindi na po ito mauusod, no, because this is already the finals week. Okay, so we are just given a week to finalize your grades and encode them in EDERP, no. So unless there will be extraordinary circumstances again, I think this will be the most definite, no, deadline of submission. Okay, so that will be December 15. That is a Tuesday. So Tuesday at 5 p.m. Okay, so again, this is already the finals week. So I hope that we are using our time. We are spending our time wisely, no, as we are all nearing, no, towards the end of the semester. Meron po bang gustong magtanong before we formally end our discussion? Wala. Sige, I'll just mute everyone kung wala naman pong gustong magtanong. Okay, ayan, may tanong yata. May tanong po ba? Nan, thank you, Piolo. Alright, so kung wala na pong tanong, that's everything that I got for you for this semester, which means that we are now formally concluding our virtual discussions, and I thank you for joining us for the entire semester. No, we know we had hard times, no, during this online semester, but we will conquer. No? You know, we will survive. And with that, again, I thank everyone for joining us for the past few months of having these online discussions. And I hope that we will have productive weeks, no, ahead of us. Sabi ko nga, patapos na ang semestre. No? So we will be indeed busy. No? But I hope that we will all achieve, no, everything that we want to achieve, no, this semester. And with that, again, maraming salamat, and I hope to see you again in the campus, or I hope to see you sometime, no, in the campus. And ayan, sige, wala na. I don't know how to end, no, but yun lang. I thank everyone, and I hope that you and your family are always safe and healthy. Bye-bye, salamat.
Thank you, sir.
Salamat din, bye-bye.
Thank you very much, sir.
Thank you,
Sige.
sir.
See you soon po. The best po kayo, sir.
Thank you po, sir.
Sabi mo lang yun. Good luck. Bye-bye. Salamat din.